Welcome! Apologies for the delay on this lesson. I had to make a couple videos today, and so it got me a little bit behind. But anyway, here it is now. We're going to talk about variables and data types, which is kind of like the first bit of actual programming that you're going to start doing. Previously, all we were kind of doing was printing things. When we started organizing code into static methods and tried to eliminate redundancy, that was the baby steps. That was the beginning of starting to think like a programmer, trying to do procedural decomposition. But now we're going to actually start working with kind of the fundamental pieces of what programming is about, which is manipulating data and storing it and printing it out and modifying it in some way, because that's really what a computer is there for. That's what they were created for, is doing large calculations and stuff that humans couldn't do by hand, and keeping track of lots of information. So that's what we're going to talk about. So first and foremost, what is data? So to a computer, data is it's just a sequence of ones and zeros. Everything fundamentally breaks down for the computer into these, switches that are in the on position or in the off position. And where it's stored is in a place called memory. And almost all computers have some kind of memory. This is an example of memory you might see in a desktop machine. This is RAM. RAM is short for random access memory. And so there are these little chips, and these little chips contain all these transistors. And those transistors can be 1 or 0. They can be on or off. And so, you've got millions and millions of these little transistors on this whole array of chips here. For this class, you're not going to need to know a bunch of the nitty-gritty details of how memory exactly works, or how Java accesses the memory in RAM. Other languages like C or C++ are going to have you're going to have to think more about those kinds of things, and that's a kind of a stumbling block for beginner programmers. Because most people have never really thought too much about how the computer actually stores information on it. But as you progress as a programmer, you will start to think about those things. But for this class, just know Java is doing stuff behind the scenes to access the things access these ones and zeros on these chips, and you don't really need to worry about it so much. Okay. All right, so to reiterate, data is all around us. All of your, if you think about like Franklin High School, you can think of Franklin as like this collection of all these students, and Power School has this, has all of the names for all the students and all of the IDs and all of their GPAs, and there's so much data there, and it's impossible to think about how would you store all that now with like a filing cabinet. You would need, if you wanted to just store 10 years of student data, you would need rooms of like file cabinets and all the teachers that have all their assignments and everything, right? So it's an impossible task to try to store all that on paper now, and so we use computers to handle a lot of this data for us. Manipulating this data, that's like really a computer's first job. All programs that you're going to write are going to interact with data in some form. They're going to manipulate it, they're going to print it, they're going to take in data from some input, and so that's really the essentials to what programming is about. And so learning how to how to store it, access it, change it, delete it, all of those things, learning how to do that work with data with the computer is the essential skill for any programmer. It's the beginning. We're just like starting our journey as programmers, and this is like what you really have to get down, I'd say. Okay. Unlike, and a last little caveat, unlike some languages you may have programmed, like JavaScript or Python, when you are going to store data, when you're going to set some information aside, in those languages, you're just saying, I'm going to set information aside. I'm just going to make a variable. In Java, you actually have to specify the kind of information that you're going to store, and that's true for C and for other languages. And there's a reason behind this having to do with memory management, which we might talk about in a kind of a side lecture later on about like what is Java doing with memory. But just know that Java needs to know what kind of information you want to store. So if you're going to store a number, it's going to be different than if you're going to store a string, then it's going to be different than if you're going to store a decimal value. So all of these kind of require different amounts of storage, and Java needs to know that it's going to save that kind of information. Okay? All right, so this is getting at data types. I mentioned a couple right there. A number, like a whole number, or a decimal, or a string. These are all data types. They're different kinds of information you might want to store. All right? And in Java, and in other languages as well, there are these kinds of primitive data types that were created in the language, and later on down this course, you're going to be able to create your own data types that are kind of combinations of these primitives, but fundamentally, all of the data is going to break down into some subset of primitive data types, you know. So here are the primitive data types that we're going to work with in Java this year. There are more than the ones I'm listing, but you actually don't really need to know what those data types are for the AP test. So if you're curious, you can always go Google Java primitives, and you'll find a page that lists all of the ones that Java has. Okay, so on the left column we have this is the official name of what that data type is. This is our Java keyword, which we'll be using shortly to save that data. And here's some examples of values that you might save as these data types. So the first data type we have up here is an integer data type. You know, integers are all whole numbers, negative whole numbers. 0 is an integer. Here's a funky one right here, 2 to the 31 minus 1. This is actually the same as the max int value. This is max. Oh man, my mouse writing skills are not very good. This is the largest integer that Java can store if you're going to use an int. There's another kind that you might use later that's called long, which gets you a even larger numbers, but this is around 2 billion. 2 billion. It's rare that you're going to need, especially if you're just counting, it's rare that you're going to need more than about 2 billion as the biggest number. But if you do need to go higher, then there's ways to do that. So these are all examples of integers. The next data type that is on this list, this is one that you've probably never heard of before, unless you've done programming in the past. But it's a Boolean data type, and we're going to get to this data. We're going to I'm just mentioning it now because it is one of our primitives. Later on down the line when we get into conditionals and if this, then do this, otherwise do that thing, and we kind of have our programs start to be smarter, then we're going to use Booleans a lot more. But just know that it is a primitive, it exists, and Boolean's values, there's only two possibilities. It's either going to be true or it's going to be false. So it's a true-false variable. So we'll see a couple examples of ways you could define Booleans. And then we have character, a character data type. Its keyword is char. Boolean was Boolean with a lowercase b. The keyword for characters is char, and that's just any single character in single quotes or single quotes. So this might actually be an error. I'm going to look this one up, but I'm pretty sure that the double backslash, if you want the backslash character, you actually need the backslash in front of it to make it a single character, considered a single character. I'll have you guys test this one out. So test me. Test. Okay. But a number 0, that's a single character, lowercase a, uppercase letters, all of those single letters are characters. This actually is not tested on the AP test, but I think it's a very important data type to be mindful of because characters are the fundamental building blocks of strings. And then here's one that's going to be pretty useful. It's the double data type, and its keyword is lowercase d. And these are, you know, decimal numbers, 1.23, negative 0.5, math.pi. Ooh, that's one that's interesting. We've never seen this kind of way of writing things before. But just, this is the Java way to access pi, if you want to use pi in a calculation, is capital M-A-T-H dot pi with a capital P. But these would be all double examples, which are just kind of like decimal numbers and different from integers, which are whole numbers. Okay. One thing to note is that I didn't write string on this list, even though we've talked about strings. Strings are not primitives, so they are not primitives. It's important. We're going to talk more about what strings are. Like I said earlier, a string is a sequence of characters, right? Strings are made up of all these characters. So it's made up of a bunch of primitives, but it's fundamentally something different. And just a little, you know, foreshadowing, a string is basically is an object. And we're going to talk more about what objects are later on down the line. Okay. Okay, so when you want the computer to store some data, store any kind of information, you gotta have to specify 3 things. I've already kind of clued you into this. The first thing that you've got to specify is what kind of data you want it to store. This is different from other programming languages, as I said earlier. JavaScript and Python and some other languages don't require you to specify what kind of data it is, but Java and C, C++, and more of the lower level languages do. Then you also have to specify the name. So how are you going to reference this data? So for example, in math, when you have variables, you use like x and y. Those are usually pretty bad names for variables in programming because they don't have any context. They lack any kind of context of what the situation is. So better names would be stuff like my name or my age, and we'll get an example in shortly. So, and then you also have to specify what the value is. So what is the actual number or string or character that you're storing into the computer? This set of 3 things, a piece of data. A piece of data is basically just a variable, okay? So variables can be changed. You can change the value of them while the program is running. And that's why it's called a variable, because it's changeable. So I'm going to kind of use data and variable interchangeably. But variable is specifically that, that name with that value attached to it, okay? Okay. So let's talk about how you actually declare, how you actually create these variables, this data. And the first step that you have to do is declare it, like we did with methods earlier. So declaring a variable is basically saying, hey computer, I'm going to I want to hold this information. I'm going to specify what kind of information I'm going to hold and what I want to call it, just like we did for methods, where we specified the name of the method. So we have a type, which comes first, followed by a name, which you have control over this. But what you can imagine, if you've got a big program with lots and lots of these variables, lots and lots of data, then the names you choose are really important, because if they're too similar or they're not referencing the thing that you want them to reference, the names they don't match the data, then it gets really confusing and really hard for you as the programmer to know what is that data for, what is that variable doing. So there's too many things going on. So good names, good descriptive names for your variables are super, super important. Especially too, if someone else is going to come along and read your code. If you've got all these random variable names, X, Y, what have you, but they don't talk about what they're actually referencing, what they're actually storing, then reading code is very tough. It's very hard to understand what's going on. So the names are important. So important. All right. Hopefully I've driven that home. Names. We'll get more practice with it. Okay, so here's some example declarations that you might have for variables. Say you wanted to store your GPA and write a program that calculated what your GPA would be based off of, what your, say you are looking at what you have right now, and then you're like, hey, I want to know what could my GPA be if I got these grades in my 6 classes I'm taking right now. Then you'd want to store your GPA into some variable, and it's a double because GPAs aren't exact. Usually they're not. They're going to be some decimal number, 3.5, so forth. Your age, maybe you are writing a program that has something to do with referencing an age or something. So you would store that into an integer, because that's usually going to be a whole number. If you want your middle initial, that would be a character. So char middle initial. Here's an example of a Boolean. Maybe you wanted to have a weather program or weather app and do something if it was sunny and don't do something if it wasn't. So is sunny is like true or false. You could have a city, which would be a string. So that's a bunch of characters together, or any other kind of sequence of letters would be a string. So these are some example declarations of variables. Okay, so after you've declared a variable, you've said, okay, I'm setting aside this memory. I'm going to store some data here in this name. Then you can assign a value to it. So the way to assign a value, you're basically storing that value into that variable, is you use the name that you specified earlier, and then equals and value. And this is a different kind of equals from how you see them in math classes. This equals symbol has a direction. It takes whatever's on the right, so this value over here, and it stores it in the thing on the left. Okay, so it is not an equals like math class. I'm going to reiterate this. The single equals in Java, in programming, is not equals in math. This is a directional thing. It says take the thing on the right and store it in whatever's on the left. Okay? So we're going to store whatever our value is into that variable that we have named over here on the left. So here's some example variable assignments. So if we had those variables declared from earlier, one of them was double my GPA. So you could say my GPA equals 3.5. You could say age equals 15. You could say middle initial equals n with single quotes around it, single quotes for characters, double quotes for strings. Is sunny could be true if it's a nice day out, or it could be false if it wasn't. City, which was a string, that could be Seattle in double quotes. So over here on the right, we have all these literal values. So we have literal values. And on the left, we have names. So these guys are getting stored into those variables on the left. Okay? That's how we assign values. Important thing to note, the variable has to be declared before you assign it. If you tried to assign the value to something that hasn't been declared yet, you're going to get a compiler error. It won't work. You can declare and assign at the same time. If you know what the value will be when you create it, then you can just do this all in one line in a single statement and save yourself a little time. So this is how you can declare and assign a variable. It's kind of a mismatch of those two things where you declare and you assign. So you just declare, assign all at the same time. So here's the declaration part where we have a type and a name. And then here's the assign part, so that's our declaring. And then assigning, we have over here, that's the name equals value. And so they kind of overlap right there where the name is, because you don't need to say the name again if you already have the name in that statement. So a couple examples like we had from earlier, you can just put double my GPA equals 3.5 or 3.5. You can say string city equals Seattle in quotes. And this does the declaration and assignment at the same time. Okay. One thing to note, you can only do this once. You can only do this once. You can only declare and assign one time. Once. Oh boy. I love the writing with a mouse. Maybe I'll get better at that someday, but it's unlikely. So you can only do this once. If you want to change the value of it, you have to use the assign syntax, and you'll see that in a second. Okay. You can't declare a variable with the same name twice. When you declare it the first time, you are saying, all right, set aside space in memory for this data, and I'm going to reference it with this name. So you can't declare it again because you've already set aside space for stuff with this name. If you want to change the value, it's what it is. It's a variable. You're allowed to change its value, what's stored there. You just use the assignment syntax. So, for example, suppose you had my GPA declared and initialized like this. It's 3.3. So you create the variable with the declaration over here, and then you assign it with 3.3 over here. So we have this number 3.3 stored in my GPA. If I tried to do this, change it to 4.0, this is going to throw an error. This won't compile because we've already done the declaration up here, and I'm trying to redeclare right there. So this is an error because I've already declared it. So you can't declare twice. You can, however, do this line. This is okay. So this is okay, and this line's bad. You can actually change its value, and to change it to 4.0, wouldn't that be nice if it was as simple as that? To change my GPA to 4.0, all I have to do is say, my GPA, which is the name, equals 4.0. That's the assignment syntax that we talked about earlier. This will change whatever's stored in my GPA to 4.0. And it was 3.3 before, so that will update it. So, okay, here's a little test yourself. Go ahead and try to declare and assign 3 variables that will store your name, your age, and your height. You can do this in a Java program like in IntelliJ, or you can just try to do this on paper and see if you get what I get. Okay, so declare and assign 3 variables to store your name, age, and height. Okay, here's the answer. So I want to store my name, so I have a string because a name is going to be a sequence of characters, so it's a string. And so we have a string with a capital S, name, which is the name of the variable. In this case, the name of the variable is name, equals sign, Mr. Ackerman, with a period, and then double quotes around the whole string, and then a semicolon at the end. And then for the age, that's an integer. Int age equals 29. If I use these videos next year, this will be incorrect. But anyway, there's our age variable, and then height, that's going to be stored into a double because I'm not exactly 5 or 6 feet. I'm actually 5.75 feet roughly. So that's 5 3/4, which you could convert to inches if you're curious. But anyway, this would be our 3 variables, name, age, and height. Your values, you should have the same declarations over here, but your values over here will be different. They're going to reference you, So it's okay for the values to be different. Okay, so we've talked about storing this data, but how do we actually use it? Well, the simplest way to use it is to just print it to the console. So we can print variables, and to print it, you put the name of a variable without quotes inside a print statement. So for example, I have a string, my name is Mr. Ackerman, and if I print my name is with a space, note this is a print statement, followed by a println with my name, which is the name of our variable. So we have my name here, which is the name of our variable. Then what do you think is going to print out? That's correct. We're going to get my name is, so we'll have my name is with the space. So this is my name is with the space. And then when we do the printing of Mr. Ackerman, so when we do this, or excuse me, when we do the printing of the variable my name, it's going to say, hey, I'm not going to print my name. I'm going to go find the value, which is over here. This is the value. And we're going to go replace my name here with the value. So we're going to go find wherever my name, whatever value my name is, whatever value is stored there. And we're going to replace everything that references my name with that value. And then print that. So that's why Mr. Ackerman gets printed down there. Okay? All right. Another way you can do this, so you can actually glue the variable value, the value of the variable, to a string using the plus operator. And this is actually called string concatenation, kind of a fancy word for it. And what you're going to get is a longer string that's made up of those smaller strings, and it's going to follow it in order. Okay? So for example, maybe I have an int, my age, and it's equal to 18. And I want to print out this, age, and then whatever the variable is stored. So I can just use a single println and glue the variable to the string. And this is going to, instead of printing my age, literally, it's going to go find, remember, it's going to go find whatever's stored in my age. And then it's going to go and replace it with whatever that value is, okay? So we're going to get 18 is going to get, this is going to be 18, and then we glue that number 18 onto the end of this string here. And what will we get when we do that gluing? Well, you're going to see age, colon, space, right here. So there's the age, colon, space. And then the value of my age, which is 18. So that's another way, maybe a faster way to print these variables where you don't have to write multiple print statements over and over again. Okay, so this is called string concatenation. You're gluing a string to something else. You're concatenating the strings together. It's kind of a fancy word for, yeah, combining strings, basically. And you can combine as many strings and variables as you want, all in the same line. It just moves from left to right. Okay, let's try it. So now print the three variables, name, age, and height, that you did earlier to the console, including descriptions of what each variable is. And I want your output to look like this. My name is, space, whatever your name is, with a period at the end. I am blank years old, whatever your age is, with a period. I stand blank feet tall with the period. Okay, so go ahead and try this out. You can either use IntelliJ or just write down your answer on a piece of paper somewhere and pause the video when, right now and resume it when you're done. Okay, so here's the answer. So the first part, we want to print out whatever the value of name is. So it's going to look something like my name is, with a plus, with the variable name. So we have a name, this is our variable right here. And then we have another plus afterwards, because we need that little period to show up after the value of the name. So this is going to glue the period on afterwards, okay? So this is a little tricky. I didn't actually show you this, but you might have figured it out. And then we're going to print out I am space plus age plus years old. And remember, this again is not the string age. It is going to be the value of whatever age is. So it's going to go find your age you saved and use that instead of the string age. It's not a string because there's no quotes around it. And let's look at the next one. Similar to the one above it, I stand blank height feet tall. So it's going to go find the value of height and use that instead of height as a string, right? It's going to go find that value. Okay. Lastly, let's talk about other ways you might use variables. So that we just talked about printing their values. You can also use a variable to modify another variable's value. So you can kind of use variables with other variables together. So for example, suppose you had a variable for your age and you set it equal to 18 because you're 18 this year. Hooray. You can vote, you're almost out of here. And then you know the current year, that's equal to 2017. And so then you might be curious, based off these two values, you could calculate how old or what year it was when you were born, right? Because your birth year is the current year minus how long you've aged. And so this is going to work exactly as you might expect. Where'd my mouse go? There we go. This is going to work exactly as you might expect, where current year is equal to 2017 and my age is equal to 18. And so we're going to just replace this with 2017 and replace this with 18 and then do the calculation and save that into birth year. So what do you think birth year will hold after the code above executes? And if you guessed 1999, then you are correct, because 2017 minus 18, so if we subtract these two values, then you're going to get 1999 as a result. So that's what gets stored there. Last little bit before we close out on this lesson is when you use the variable, when you assign it a value the first time, this is called initialization. So the very first time you give a variable a value, it's called initializing the variable. And if you ever try to use a variable before it is initialized, you're going to get an error. And it's okay, this is fine. You'll just have to go back and see, well, I must have just declared something but not actually given it a value. So going back to this example, if we've got the three variables, my age, current year, and birth year, we're going to have an error when we try to run this line down here. These first two lines are good. This is fine. This is fine. This creates a variable my age, gives it the value 18. This creates a variable current year, doesn't give it any value, but that's okay. You can just declare the variable. And then when we try to run this line, what do you think is going to happen? Well, this line is going to say, okay, go find me current year. And it's going to say, okay, current year. Well, you didn't store anything here. So it's like, I don't know what to do. you didn't give me a value. So I don't have something to subtract my age from. You know, I can't guess what the value is. So you get an error here because it hasn't been initialized. You can imagine when the computer gets there, it goes to look it up, but there's nothing there. So it just says, no, I'm sorry, I can't do anything. So this is an error. This error can be fixed either by not using current year here or by giving current year a value. So current year was not initialized. Initialize. Initialize me. That's what I'm writing. Initialize me. Oh boy. Alright, someday I'll get better at writing with a mouse, maybe. Okay, if you're curious about some practice of problems that highlight things we've talked about in this lesson, there's a list of some. There's some at the beginning that get into order of operations. You can either read about that section in the textbook or watch the next video about how do you actually do order of operations with Java. It behaves a lot like math, but there's a couple of there's one new operator that you've never seen before, and that's the percent sign. So we'll have a lesson where we just talk about what percent does and how you use it and order of operations. So hopefully you found that video informative. And please leave feedback in the comment section or comment section of YouTube, or you can leave feedback on Schoology. Thank you. Bye-bye.